The dawn of forging. Let's dive deep into the fascinating history of forging. We're talking about shaping metal with fire and force, a craft almost as old as civilization itself. Imagine our ancestors, way back in the Stone Age, discovering shiny nuggets in a stream. This wasn't your average rock. This was native copper, naturally occurring metal they could pound into tools. That was the first step. Then came fire. Around 4000 BC, someone figured out how to melt copper. Suddenly you could pour it into molds, making tools and weapons way better than stone. That was a game changer. But copper was soft. They needed something tougher. So they started experimenting with other metals. They discovered that by adding a bit of tin to copper, they could create bronze. Bronze was harder and more durable, leading to the Bronze Age, a period marked by significant advancements in tools, weapons, and art. The art of forging continued to evolve. Blacksmiths learned to control the temperature of their forges, allowing them to work with iron. Iron was more abundant and stronger than bronze, but it required higher temperatures to work with. They used bellows to increase the temperature of their forges, making it possible to melt and shape iron. This led to the Iron Age, a time of great technological and cultural advancements. Eventually, blacksmiths discovered how to make steel by adding carbon to iron, creating an even stronger and more versatile material. Steel revolutionized the world, leading to the development of everything from skyscrapers to surgical instruments. Today, blacksmithing is both an art and a science, with modern blacksmiths continuing to innovate and create. They pass down their knowledge to new generations, ensuring that this ancient craft continues to thrive. So, the next time you see a blacksmith at work, remember the long and fascinating history behind every hammer strike and every glowing piece of metal. From the Stone Age to the modern era, forging has shaped our world in countless ways. And who knows what the future holds for this timeless craft. One thing's for sure, the spirit of forging will continue to burn bright. Before we continue, if you are enjoying this video, feel free to like, subscribe, and hit the notification bell to receive future updates. Back to the Bronze Age. This era marked a significant leap in human technology and culture. Around 3000 BC, folks in the Middle East discovered that mixing copper with tin made a super strong alloy bronze. This discovery was revolutionary, transforming the way people lived and worked. This was huge. Bronze tools were sharper, weapons were deadlier, and civilizations boomed. Cities grew larger and more complex, trade flourished, and new forms of art and architecture emerged. The Egyptians were masters of bronze. They made incredible statues, jewelry, and even weapons like the khopesh, a sickle-shaped sword that could really mess up your day. Their expertise in bronze crafting allowed them to build monumental structures and intricate artifacts that have stood the test of time. The Hittites, another ancient civilization, figured out iron around 1500 BC. This was a game changer in the ancient world. Iron was even tougher than bronze but harder to work with. The process of smelting and forging iron required higher temperatures and more advanced techniques. You needed serious heat to forge it. Blacksmiths had to develop new methods and tools to handle the intense heat and hardness of iron. Still, iron gave them an edge in battle, literally. Iron weapons were stronger and more durable, giving armies equipped with them a significant advantage over their enemies. This shift from bronze to iron marked the beginning of a new era in warfare and technology, paving the way for future advancements in metallurgy and engineering. For centuries, blacksmiths were the rock stars of the metal world. They were the artisans who could transform raw, unyielding iron into objects of utility and beauty. They were the ones who could take a lump of iron, heat it up in a fiery forge, and through sheer skill and muscle, hammer it into everything from horseshoes to swords. The process was as much an art as it was a science. Imagine the skill required to craft a perfect horseshoe, or the precision needed to forge a balanced sword. Each strike of the hammer was a step closer to perfection. It was hot, sweaty work, but somebody had to do it. Then came steel. The advent of steel marked a significant turning point in the history of metalworking. Around 500 BC, folks in India figured out a way to add carbon to iron, making it super strong and flexible. This innovation didn't just improve the quality of metal, it revolutionized the entire industry. This was a game changer. The addition of carbon to iron created a material that was not only stronger but also more versatile. It could be used in a wider range of applications, from construction to weaponry. Steel was the key to better tools, weapons, and even armor. The superior strength and flexibility of steel meant that tools could be sharper, weapons more deadly, and armor more protective. Think of the Roman Empire. Their legions conquered much of the known world, and their iron and steel weapons were a big reason why. The Romans were masters of metalworking, and their innovations in weaponry were unmatched. Their legions were equipped with weapons that were not only effective, but also durable. The combination of iron and steel in their arsenal gave them a significant advantage over their enemies. From the gladius, their short sword, which was perfect for close combat, to the pilum, their deadly javelin, designed to penetrate enemy shields and armor, Roman weapons were feared throughout the ancient world. Their mastery of iron and steel was a key factor in their military success, and it left a lasting legacy that continues to influence metalworking to this day. Fast forward to the 18th century. The Industrial Revolution hit Europe like a thunderbolt, and forging was about to get a serious upgrade. Water wheels and steam engines replaced muscle power, making it possible to produce metal goods faster and cheaper than ever before. With these new machines, we could crank out tools, parts for engines, and even railroad tracks. The world was changing, and forging was keeping pace. But we weren't done yet. Not even close. Powering up machines take over. The 20th century brought even more innovation. Electricity became the new power source, making factories cleaner and more efficient. We developed new types of forging like drop forging, where a heavy hammer slams into hot metal to create complex shapes. Think about the car industry. Drop forging was essential for making engine parts, crankshafts, and axles. Without it, we wouldn't have the millions of cars on the road today. Getting precise new forging methods. But we weren't just making things faster, we were making them better. New alloys like stainless steel and titanium were developed, each with its own special properties, and we found ways to forge them into incredibly precise shapes. Take a look at a jet engine. It's a marvel of engineering with thousands of parts, many of them forged from high-strength alloys. Without precision forging, we wouldn't have jet travel, space exploration, or even modern medical implants. Beyond the hammer modern forging techniques. These days, forging is more high-tech than ever. We're not just talking about hammers and anvils anymore. We've got computer-controlled presses that can exert thousands of tons of pressure, shaping metal with incredible accuracy. One cool example is isothermal forging. We heat both the metal and the dies to the same temperature, which gives us even more control over the final shape. This is used to make super strong parts for airplanes and spacecraft. The digital age computers enter the forge. Computers have revolutionized just about everything, and forging is no exception. We use computer-aided design, or CAD, to create three-dimensional models of parts, and computer-aided manufacturing, or CAM, to control the forging process. This means we can design and create incredibly complex parts with incredible precision, all thanks to the power of computers. But hold on, because things are about to get even more futuristic. Artificial intelligence in forging, a new player that is reshaping the industry. Artificial intelligence, the same technology behind self-driving cars and facial recognition, is now being used in forging. We're talking about smart machines that can learn and adapt, making the whole process even more efficient and precise. Imagine a forging press that can analyze data from sensors in real time, adjusting its parameters to ensure perfect results every time. That's the power of AI in forging. The future is now. AI is changing the game. So, how is AI specifically being used in forging today? One big area is predictive maintenance. AI algorithms can analyze data from machines to predict when they're likely to fail. This means we can fix problems before they happen, reducing downtime and saving money. AI is also being used for process optimization. By analyzing data from past forging runs, AI can identify ways to improve efficiency, reduce waste, and enhance the quality of the final product. Forging ahead. What's next for AI and forging? The future of forging is bright, and AI is going to play a huge role. As AI technology continues to evolve, we can expect to see even more innovative applications in forging. Imagine a world where robots work alongside human operators, where AI designs and optimizes forging processes in real time, and where the quality of forged parts is consistently flawless. That's the future that AI is helping to create, one piece of metal at a time. Thank you for watching. If you enjoyed this video, feel free to like, subscribe, and hit the notification bell to receive future updates.